Okay, here we are again, and we're going to be working on problems 36 through 40. So on this part, we want to factor and simplify the trig expression. So I notice the numerator is a difference of squares. So I'm going to rewrite the difference of squares as the sine of x plus 1 and the sine of x minus 1. Some basic factoring, and you put that over the sine of x plus 1. Oops. And that cancels with that, and your simplified expression is choice D. The next one, we're going to take out the greatest common factor, and that's going to be take out the sine squared of x. And then we'll have 1 plus cotangent squared of x. And if you notice that in the previous page, let me just take these identities, I'm going to cut and paste them. So I'll cut and paste the previous identities from before, and let me just copy that, and I'll bring that onto this page, and let me shrink it down a bit and move it over so we have them handy. And I don't know what happened there, so let me just try to move them around again. Okay, we're back, I think, and I don't know what happened with my OneNote, but I had some errors. So anyway, so we're back, and we have this identity here that we're trying to resolve or simplify. And we have the sine squared of x that we factored out of number 37, and we're left with 1 plus cotangent squared. And if you have your identities handy, you'll see that 1 plus cotangent squared could be replaced with cosecant squared of x. And if you remember, cosecant squared of x is 1 over sine squared of x. So when we multiply these, they just cancel out, and all that work resulting in just the one value. Isn't that crazy? Looks like I got a little bit, I wasn't proofreading, so number 37 down below is the same one. And now we have prove the identity. So let me just rewrite that on the lower sheet. I'm just going to rewrite 38 here so I have some room to work. Cosine squared of theta plus 1 equals 2 cosine squared of theta plus sine squared of theta. Okay. Well, there are many ways to do this, but remember, we don't want to be moving terms from the left side to the right side. So what I'm going to do is I'm going to rewrite the 1 as sine squared of theta plus cosine squared of theta, because I know from my Pythagorean theorem that sine squared of theta plus cosine squared of theta equals 1. And what I'm going to get from this is I'm going to see that I have 2 cosine squared thetas plus sine squared theta on the left, which matches what I started out with on the right. On the next problem with number 39, I want to solve this equation, this trig equation. So the first thing I'm going to do is I'm going to factor out what's common to both. So I'm going to take tangent of x outside, and I'm going to have just 2 cosine of x plus root 3 left over. So now remember, in equation solving, when we have two things multiplied that equal 0, it indicates that both terms should be set to 0 to find all solutions. So on this one, I just have to remember my reference angle for when tangent of x equals 0. That would happen at 0 degrees. And this repeats itself at x equals 180 degrees. And at x equals 360 degrees. So these would be the solutions if you want to know all the solutions between 0 and 360 inclusive. And on this side, I simply take 2 cosine of x, set that equal to negative root 3. I divide both sides by 2. And now I'm trying to figure out the reference angle that when I take the cosine of it, I get root 3 over 2. Well, I draw my 30, 60, 90 because that's what that reminds me of. There's 60, there's 30, there's 90, and this would be root 3. This would be a 1 value, and this would be 2. So the adjacent over the hypotenuse is cosine, and that would indicate that my reference angle has got to be 30 degrees because it states that the angle is negative. What quadrant do I have a 30 reference in where cosine's negative? Well, that would be a 150 degree angle and also a 210 degree angle. So my two answers for that would be x is equal to 150 and 210 degrees. My four answers that would work are, you put it all together, actually 5 answers would be 0, 150, 180, 210, and 360 when you combine all of the solutions. And that's again if it said find all solutions for x between and including 0 to 360. I hope this has helped, and I will be starting off with 40 in the next video, but this one switches gears to doing the areas of triangles. So we'll probably switch to other applications of triangles for that. Hope this helped.